Building a powerful AI system, it seems complex, right? But honestly, it all boils down to one critical first step, your data. If you get this wrong, nothing else you do is going to matter. And especially if you're prepping for a technical role, getting this foundation right is just, well, it's non-negotiable. So let's get into it.
So let's start with the core challenge here. You've got this wealth of information, a giant PDF, a complex website, you name it. How do you actually get that raw, unstructured data into a format that an advanced AI model can understand and, actually use? This is the very first problem we've got to solve.
The whole process for this has a name. It's called a Retrieval Augmented Generation, or RAG pipeline. And the very first step in that pipeline is ingestion. You can think of it like opening the front door to let all your data inside. And that front door is a special tool called a document loader.
Okay, so let's lock this concept in, because this is a classic interview question. If someone asks you, where does the RAG process truly begin, the answer, every single time, is with loading the documents. It's the starting line for everything that comes after. And honestly, it's the most underestimated step. A failure here just cascades through the entire system and can make even the most powerful AI totally useless. A good way to think about document loaders is to picture them as the crew at the receiving dock of a factory. Their job is to go out and collect all the raw materials, the PDFs, the web pages, the text files, and bring them back to the factory floor, which is your AI system. Simple, right? But without them, the factory has absolutely nothing to work with. So their job is this simple, but absolutely crucial, three-step process. First, they connect to wherever the data is. Second, they pull out all the raw text. And third, they convert it into a standardized format. This makes sure that no matter where the data came from, your system sees it in one consistent, predictable way. And what's great is that doing this isn't some super complex coding challenge. Libraries like LangChain make it surprisingly simple. I mean, you can see in this example, it's really just 2 steps. You point the loader at your file, and then you just call the load method. That's it. The library handles all the heavy lifting behind the scenes.
So, let's put a bow on this. Here is your confident, interview-ready explanation of what document loaders do. They're the entry point that takes all this diverse, external data and standardizes it, so the rest of the RAG pipeline can actually do its job effectively.
Okay, so the data is inside our system. Awesome. But we've kind of just traded one problem for another. A 100-page document is still just one massive, unusable block of text. To make it useful, we've got to break it down into smaller, more meaningful pieces.
This brings us to a really fundamental limitation of large language models. They have this thing called a context window, which is basically a limit on how much text they can look at in a single go. You can't just feed them a giant document and expect a good result. It's just too much information for them to handle all at once. The solution isn't to just randomly chop the text up. We need an intelligent tool, and that's where something like the RecursiveCharacterTextSplitter comes in. Its whole job is to break text down into smaller chunks while trying its best to keep the original meaning and the logical flow of the sentences and paragraphs totally intact.
And this slide just illustrates the difference perfectly. A bad, arbitrary split might cut a sentence right in half, completely destroying its meaning. But a smart, semantic split, well, it looks for natural breakpoints, like the end of a paragraph or the end of a sentence. The goal is always to create chunks that make sense on their own.
Now, why is it called recursive? That word might sound a little scary, but the idea is actually pretty simple. It just means the tool tries to split the text using a list of separators, in a specific order. It starts with the biggest, most logical one, a double line break, for paragraphs. If the chunks are still too big, it recursively moves to the next separator on its list, like a single line break, and tries again, all the way down to individual characters if it absolutely has to.
When you actually implement this, you're going to set 2 key parameters. Chunk size is pretty straightforward. That's just how big you want each piece to be. But chunk overlap, now this is a clever little trick. It makes each new chunk include a little bit of the end of the previous one. This is so crucial for maintaining context, making sure the AI doesn't miss a key idea that happened to fall right between 2 chunks.
And here is the key takeaway for an interview. This tool isn't just a technical step, it's absolutely essential for achieving high-quality results. Better chunks lead to better embeddings, which ultimately leads to more accurate and relevant information being retrieved by your system later on. It all connects.
So far, we've been talking about a nice, clean source, like a PDF. But let's be real, the world is messy. What happens when your source is a web page just full of junk? This is where data preparation gets even more critical.
I mean, think about it. When you load a web page, you don't just get the article you want to read, right? You get a whole lot of extra noise packaged right along with it. And this noise is not just useless for our AI, it can actually be harmful.
And by noise, I mean everything. You get navigation menus, footer links, those annoying cookie banners, ads everywhere, and a ton of behind-the-scenes code. If we feed all of that into our system, the AI is going to get confused and might base its answers on an advertisement instead of the actual article content.
You know, a really great way to think about this is like preparing vegetables before you start cooking. You have to wash off the dirt, peel the skin, and cut away any bad parts. You only want to cook with the good, clean part of the vegetable. The exact same logic applies to our data.
And the parallels here are surprisingly direct. Removing all the scripts and styles, that's just like washing off the dirt. Stripping away navigation menus and footers, that's like peeling the skin. And getting rid of ads, well, that's like cutting out the bad spots. In both cases, the goal is exactly the same. Isolate the high-quality core that you actually want to work with. So, to do this kind of customized parsing, we use a fantastic tool called Beautiful Soup. It's like a surgical instrument for HTML. It lets us tell the system, hey, I only care about the text inside the main article tag and the P paragraph tags. Just ignore everything else. This is how we extract just the good stuff.
So let's step back for a second. Why have we spent all this time talking about loading, splitting, and cleaning? Why are these prep steps so incredibly important before we even get to the AI part of the AI? Well, it all comes down to the most fundamental principle in all of data science and AI: garbage in, garbage out. The quality of your output is directly and completely determined by the quality of your input. A powerful model just can't save you from messy, irrelevant, or poorly structured data. It's as simple as that.
So by following these steps, you've done the really hard work. You now have high-quality, clean, and beautifully structured chunks of data. You're now truly ready for the next phase in the RAG pipeline, which is all about transforming that text into a format that a computer can search through at lightning speed. So what do you think that next step is?